Today we have Mr. Sunil Motwani, Country Manager, Sales and Services at MathWorks. Hi Sunil, how are you doing?
I'm good, Priya. Thank you. Nice talking to you today.
Great. It's a pleasure to have you us at our podcast, and I'm sure everybody around you, your family is doing healthy and safe.
Yeah, they are doing good, Priya, and hope the same for you and your family.
Great. Thank you so much, Sunil. So, let's start with telling our listeners about what MathWorks is, its specialization, and the services it offers.
Sure. Just to give you a little bit of history about MathWorks, MathWorks was established in 1984. We are headquartered at Natick in Massachusetts, US. We make software tools that help engineers and scientists do their math and technical computing. Uh, They also use our tools for modeling and simulation of engineering systems. Today, we have more than 5,000 staff across 33 offices worldwide, developing, selling, and supporting more than 100 products across MATLAB and Simulink family. On top of our products, we have over 500 third-party solutions who have built different applications on MATLAB and Simulink. We have customers in more than 185 countries and a user base of more than 4 million users who use our tools to accelerate the pace of engineering and science. In addition to our software products, we offer training and consulting services to our customers to help them adopt our tools in a workflow that gives them return on investment, on the investment that they make on our tools. It helps them save time and cost to design and develop their products. In terms of industries, we serve multiple industry segments, and most leading companies across these segments use our tools. In addition to industry, top universities in the world use our tools to teach various subjects, and there are more than 2,000 plus MATLAB-based books written in 27 different languages. The idea is to improve the learning outcome of students when the professors use our tools to teach various engineering subjects to them.
Great. That's something interesting, Sunil. What MathWorks is doing, and I'm sure the products that you spoke about are actually helping engineers easy of their lives and focus more on the efficiency and productivity as well. Um, all technologies are born out of purpose. So for example, search engines were created to sort through the massive amounts of data online, and with each new upgrade, technology compounds existing technologies to create something better than what was previously used before, and it goes on. So with the lightning speed of technological evolution, it is no wonder that many people have struggled to keep up with it. And to be fair, the scope of technologies expands is so great. Wrapping everything up into a single blog post is practically impossible. So when we're talking about the purpose of technology, so with what mission MathWorks was set up, can you tell us about your journey since the inception of the company?
Yeah, Priya, as I said, we started our journey in 1984. At that time, the co-founders of MathWorks recognized the need amongst the engineers and scientists for more powerful and productive computation environments beyond those that were provided by languages such as Fortran and C at that time. So in response to that need, they combined their expertise in mathematics, engineering, and computer science to develop MATLAB, a high-performance technical computing environment that combines comprehensive math and graphic functions to give users a powerful high-level programming language. In addition to MATLAB, over the years, we developed Simulink, a product for simulating non-linear dynamic systems. Uh, in addition to these two platform products, we have, over the years, extensively created add-on products for specialized application areas that include control systems design, signal processing and communications, image processing, test and measurement, computational biology, and financial modeling and analysis. The mission of the company from the beginning has been to give tools to engineers and scientists that would help them accelerate the pace of discovery, innovation, development, and also learning in engineering and science. So we have worked, over last 35 years plus to provide the ultimate computing environment to scientists and engineers for technical computation, visualization, design, simulation, and implementation of their ideas into reality. So the tagline of the company has been to accelerate the pace of engineering and science by providing right set of tools to help engineers and scientists do their best work.
Right. I think what MathWorks is doing and with what mission they have been set up is something very valuable because we understand that when we're talking about engineers and scientists are always occupied or equipped with something very complex tasks. And with you coming into the picture and helping them pace up their productivity, I think it's going to add value to the overall economy as well. So, when we're talking about technology and computing software, as more existing technologies are stacked onto each other and developed into something greater, consumers and businesses alike can expect to see more opportunity with future technology. So, technology will be faster, the ability to accomplish more, and everything will become more streamlined to get more work done easier. So, while we don't have the ability to predict the future, we can offer speculation on technologies evolution. So we are constantly seeing emerging media and new trends in technology to follow up. So when we are going through such evolution, can you tell us about your role and your contribution towards the company and of course the industry as well?
Yeah, talking about myself, I started my career way back in 1988.
Mm-hmm.
First with a sales job in a PC manufacturing organization at that time. And I remember in those days, I used to sell different versions of what were called as IBM compatible personal computers. These were known as PC, PC XT, and PC 80. XT standing for Extended Technology and 80 for Advanced Technology. The operating system of those machines at that time was Microsoft DOS disk operating system. It used to come on a 5 and 1/4 inch floppy drive. The memory capacity of the computers were in the range of 640 KB to few MBs. Today, file size of some of the Excel sheets and PowerPoint presentation that we create is more than the size of the entire RAM that those machines used to have. So I've certainly witnessed the growth of computing technology over last 30 years plus. Today we talk about gigabits of RAM and terabytes of hard drives on the machines. But going back to my journey, from working for a PC company, I moved over to working for Hewlett Packard and Agilent Technologies in their electronics test and measurement division, selling electronic test equipment to multiple industries like telecom, electronic manufacturing, and others. I joined MathWorks in 2008 from the time we started our operations in India. And we started with our first sales office in Bangalore. And over the years, we have significantly grown our operations and our business in India. We serve multiple industry segments, automotive, aerospace, defense, communications, semiconductor, electronics, industrial automation, etc. And I have seen these industry segments grow in India in last 30 years, both with local, big, small, and medium enterprises, and also multinational corporations bringing in their R&D operations in India. And talking about these R&D operations, I have witnessed them really grow up in the value chain in terms of the value they provide to their headquarters for the design and development work that happened in India. The first ones to come to India at that time were semicon companies, and they started with very basic, VLSI design work that they used to do in India at that time. And today, some of these companies are churning out latest, microcontrollers and other chipsets which are designed and developed in India. Similarly, I've seen a big growth in automotive R&D in India happening over the last few decades. The initial work that used to come to India was more around verification and validation of the systems that were designed outside of India. But today I have seen these R&D organizations working out of India, contributing to complete design and development of subsystems and systems for their parent organizations. The other big market that we have addressed over the years is the academic market in India. And this has also grown significantly in the last 20 plus years in terms of the number of universities and colleges that are offering engineering courses in India. And at MathWorks, we address fairly big academic market because our software is extensively used for teaching courses like signal processing, communications, control systems design. And we have worked on multiple initiatives. I have been personally involved in some of them to improve the quality of engineering education in India. One of the organizations we have been working very closely with is called Indo-Universal Consortium for Engineering Education. That has been set up with of improving the quality and global relevance of engineering education in India. So that's one effort we have been doing. And on the industry side, over the years, we have worked in collaboration with various industry bodies to see how we can build and grow the ecosystem for these industries in India, helping them building skill sets among the engineering resources and other human resources, supporting and growing the startup ecosystem for these industries, and helping the well-established industries bring in innovative changes in their design methodologies and workflows so that they can get their products faster to market and they can improve the cost factor in their designs. So yeah, over last 30 plus years, Priya, I have seen significant changes happening both on the academic side as well as on the industry side in terms of the way technology and tools have been adopted for fostering innovation.
Definitely, Sunil, and thank you for sharing with us your journey from the scratch that you told us, and your experience and your contribution towards the industry is quite motivational. And moreover, I think it guides everyone that it's very important to start something from small and then keep on growing step by step and leveraging your experience and learning more and more, and then eventually giving back something more valuable that's beneficial for both the economy and as well as the overall business scenario that we are talking about. Um, when we're talking about computing software, I think two important technologies that really come into picture is machine learning and deep learning. So because of new computing technologies, machine learning today is not like machine learning of the past. It was born from pattern recognition and the theory that computers can learn without being programmed to perform specific tasks. And researchers interested in artificial intelligence wanted to know if computers could learn from data. So this aspect of machine learning is important because as models are exposed to new data, they are able to independently adapt, and they learn from previous computations to produce reliable, repeatable decisions and results. So it's a science that's not new, but one that has gained fresh momentum. So when you're talking about such technologies, can you tell us how MathWorks as a company is contributing in the artificial intelligence and analytics industry of the nation, and how do you think the company is benefiting its clients?
It's a very good question, Priya, and to answer it, I would kind of start with our mission statement. We have always been serving engineers and scientists with the tools that would help them do their best work. And when it comes to AI and big data analytics, again, our focus has been on serving the needs of these core users, the scientists and engineers. Um, you know, so the focus really from MathWorks has been on how AI and data analytics can be used for engineering applications. One of the important focus area for us is how to make data science easy for engineers. And since we build tools, we have focused on giving them tools to access and pre-process data, build machine learning and predictive models, and deploy models to engineering and enterprise systems. In summary, or in essence, the idea is to support the entire workflow for AI or data analytics, starting from accessing data, pre-processing data, building AI algorithms and models, and finally to deploy these algorithms and models on real-world engineering systems. And we have seen with our tools, engineers and other domain experts have quickly been able to use data science to and machine learning to deploy them on engineering systems. Eventually, our focus has been how do we make domain experts use data science as a technology to improve on their work. And we are seeing applications of AI with our software across multiple industries today, from aerospace and automotive to biotech, energy production, financial services, medical devices, and many other engineering systems. And over the period of last few years, we have taken feedback and learnings and feature requests from customers in all these industries, and looked at how we can draw parallels across many of these industries, and how our technical teams can share these learnings with our customers, making sure they are benefiting from the knowledge being created, not just in their own organization, but also across the world. And here I would like to give you a few examples from India, and I'm really proud and pleased to give this to you. I would not name the specific organizations, but I can talk about the industry that they come from and how they have used our tools for using or deploying machine learning and AI into their enterprise systems. One of the largest manufacturers of optical fiber cables in India, they have used our tools to develop and deploy machine learning algorithms to significantly reduce scrap that got produced from their manufacturing process. What this did was brought in huge savings for the company in terms of manufacturing cost. One of the largest automotive OEMs in India has used our machine learning tools for classifying road conditions. And what this has helped them to do is to then predict vehicle durability, also predict the tire life and the wear and tear of the tire. In addition to this, it has also helped them improve the fuel economy of their vehicle. Third example that I would like to quote is from a large multinational transformer manufacturing company, which has deployed multiple millions of transformers across the globe. And they have been able to use our tools to develop an enterprise-wide application to predict oil levels in these transformers by measuring temperature at multiple locations on the body of the transformer. This makes the predictive maintenance of transformers easy, as well as improve the safety of these transformers deployed across the country. An organization working in automotive area again, and specifically working in the area of building IPs for automated driving, has used machine learning techniques for radar-based object detection and classification. This is primarily to detect vulnerable road users in urban areas, which is mandatory for level 3 autonomous systems. And radar-based systems perform better than camera-based systems in poor light and fog conditions. And the radar mounted on the vehicle can very easily classify the vulnerable road users, thereby helping the system take right decisions. Another automotive tier 1 supplier has used AI techniques for quickly developing what we call as powertrain control functions to meet the stringent emission norms like Bharat Stage 6. There is another very interesting example from building automation, where large buildings and malls have heating, ventilation, and air conditioning systems, popularly known as HVAC systems. And this building automation company has used our machine learning tools to regulate buildings' internal temperature and humidity so as to minimize total energy consumptions based on weather forecasts and the footfall of people expected in the mall. So there are really very good, interesting applications where engineers have used our tools to innovate and come out with new solutions, not just helping their own organization, but also helping the users of of their products.
Amazing. I think thank you first of all for sharing some real world use cases where MathWorks has been used and how it has actually helped engineers across different industries. And I really like the point of how you highlighted that you're making the companies making data science easy for engineers. We all know that data science is the hottest job of the 21st century, but as fancy as it sounds, it's not that easy. You know, data science is a huge and a broad concept, and it is also complex at the same time. So it's quite fascinating to see how MathWorks is leveraging technology to support engineers who themselves can again, bolster the technology space. Nice. Um, Moving ahead, we discussed about machine learning, so another technology is deep learning, which is on a rage and is gaining much popularity due to its supremacy in terms of accuracy nowadays. And major tech companies are investing heavily in deep learning as it has become necessary in every sector as a way of making machines intelligent. So one example is Google AlphaGo, of deep learning that made the headlines when it crushed Lee Sedol, one of the highest ranking Go players in the world. So when you're talking about such examples, how do you think MathWorks as a company is innovative, and what are the key partnerships and involvement done to drive the innovation?
Sure. As I said earlier, our company has remained focused on building computational tools that support engineers and scientists. Um, So on top of our two platform products that we have, MATLAB and Simulink, over the years we have added additional tools to take care of specific application areas. For example, for a communication engineer, way back we added additional tools on top of MATLAB for modeling complete communication system end to end. So specific to AI and its applications, on top of MATLAB, we have tools like statistics and machine learning toolbox. And you mentioned deep learning. We actually have a separate toolbox for deep learning called Deep Learning Toolbox, which helps engineers to very quickly use deep learning as a technology to build engineering applications. And we are seeing specifically a major trend in using deep learning for computer vision applications, particularly in the of medical imaging and in the area of autonomous systems, where you have cameras mounted or you have uh, you know, uh, medical machines taking different scans of the body, and from those images you need to detect specific features and come to certain conclusions. So we are seeing great use of our deep learning toolbox in computer vision kind of applications. Another area where we are seeing significant use of deep learning as a technology is on automated driving system. So for that, we not just have deep learning toolbox, we also have automated driving system toolbox, which helps engineers use our tools to deploy deep learning based models in a autonomous system as part of the overall automated driving application. We are also seeing increasing usage on technologies like machine learning in predictive maintenance area. So we have come out with specific toolbox for that application called as predictive maintenance toolbox. Another area where we have seen significant growth of analytics is in the finance domain for risk analytics application. So for that, we have a separate toolbox called as risk analytics toolbox. So the idea is to kind of, on top of MATLAB, build specific tools that help engineers and scientists adopt specific technologies for the application that they are working on. Another interesting thing I would like to add here, is that we are seeing uh, the data-driven modeling approach that, say, machine learning, deep learning kind of technologies use, and a physics-based modeling and simulation approach, which is called as first principle modeling technique. These two worlds are coming together, to create more robust and accurate models that are very close to the real world behavior of engineering assets that are deployed on the field. Uh, so look at it as a concept of a digital twin of a real asset, which you have access to in the virtual world, and you can play around, with that digital twin in the virtual world to see how your asset would behave, in some real world conditions. One of the approaches, or one of the focus areas for MathWorks, is to see how we can bring this world of modeling and simulation, working together with AI and big data analytics, that will help engineers build complete systems. Uh, I can give an example of automated driving. This is again a very trending application area. So we provide solutions to our customers for simulating a complete virtual vehicle model with all the vehicle dynamics, in a virtual scenario, and we can create road scenarios to see how algorithms, could be machine learning, deep learning algorithms, which are deployed on these systems, work in a real road scenario. So the idea is to make it possible for them to do most of their tests and validation in the virtual world, for a complex application like automated driving, uh, rather than deploying these algorithms straight away on prototype vehicles and taking them on the road.
So, moving ahead, technology is changing the patterns of our life. And there was a time when we were physically active, but now we rely on devices to do most of our work. The changes in our behavioral patterns and adaptations that are caused by these technological advances could prove to be a primary driving force behind the next stage of evolution for our human species. So, when we're talking about such technological evolution, so how do you think disruptive technologies like AI, big data, and automation are impacting today's innovation, and how has the role of a leader has changed over the years?
Okay, so I can see there are two parts to your question here.
Right.
For the first part, I think AI and big data initiatives will continue to grow in companies. But there is a challenge in bridging AI with complex engineering and scientific systems and workflows. And as I said earlier, we are trying to see how that bridging can happen. Uh, AI is a data-driven technology, whereas a lot of traditional engineering and science is driven from first principles. So I certainly see collaboration and integration between these two domains being disruptive. And in a way, MathWorks is trying to address this disruption by seeing how the best of the tooth can be used together to solve some complex engineering problems for smart devices of future, like a fully automated car. Another example that I can talk about, and you talked about automation, is how things are changing when it comes to automation of a manufacturing line. Uh, we have heard many industry leaders talk about smart factories or Industry 4.0. So smart factory is really an implementation of Industry 4.0 in some ways. So smart factories, what do they focus on? They focus on connectivity and agility, where data is used not only for monitoring the health, but also for intelligent logistics and for predicting costly failures on the manufacturing line. And this holds true for whether it's a manufacturing line for high-end MRI manufacturing, or it's in a traditional process industry where you are doing aluminum smelting, for example. But it's not that the automation did not exist in these factories earlier. We have seen automation existing for a fairly long time, with for example, robots being used on manufacturing line. It's not something very new. But what is new is, in the traditional automation world, we used to have these robots at fixed position on the manufacturing line, with a specific task allocated to them and automated for them to done. And for these tasks, the robots were manually programmed. Uh, the shift that we are seeing today is making these robots smart, making these robots collaborate with each other the way humans would collaborate on the manufacturing line. What this means is, a smart factory would actually have autonomous mobile robots moving around and collaborating with each other, thereby, uh, greatly improving the overall efficiency of your manufacturing system. The other thing, these are all, for example, if there are companies having multiple factories, all these factories can be connected to each other with data moving from all the factories to the cloud uh, to lead to what we call as planning of intelligent logistics. Also, for all these assets that are deployed on the factory, there are digital twins of those available to you, so that you can very quickly, uh, get data from these assets and plan for predictive maintenance of these assets using the digital twins. Okay. So certainly, we are going to see big transformational change that AI and data analytics is going to bring on different industries. For the second part of your question, where you talked about how we see the evolution of the role of a leader, I think what is going to happen with all this disruption is that the leaders have to really focus on how to cross pollinate innovations and learnings across different domains and industry to accelerate the adoption of new technologies in their own organizations. And in a way, our focus at MathWorks has been to help them with the tools that would help them complete workflows that in a way democratizes AI and improves collaboration between the domain experts in the organization and the data scientists in the organization. These are the kind of things that we expect leaders of future to be looking into.
Over the last few years, we have seen a vast amount of attention paid to the impact of technological development on work, and sometimes referred to as a changing world of work. That's what popular media and consultants pointed out. And we have come across newspaper headlines such as "Robots will take our jobs," and some people even suggest that advances in technology will lead to changes in the workplace, and there will be the traditional employment relationship will collapse as there's a widespread use of artificial intelligence instead of travel and the replacement of humans with artificial intelligence and robotics. So, indeed, we are seeing a rapid growth in the use of AI and robotics, as you mentioned, to automate simple and repetitive tasks such as factory work and many of back office duties, even to simplify some complex decisions, used in medical diagnostics quickly and accurately give more precise results using predictive algorithms. So, when we're talking about such things and different opinions and different recommendations are coming into picture, what is your point of view on the current scenario of the overall landscape of technology, not just AI and big data analytics? What is your viewpoint and how do you see the future?
See, I mean, we have to accept that AI and big data analytics is going to stay here. And the reason that it's being driven in a large way today is because we now have the computing power, to manage huge data, and we have computing power to model, build, and train complex algorithms that can handle this data. And you will hear business leaders talk about this digital transformation. So in a way, AI is imperative. A Gartner study actually shows that we are going to see a 10 times increase in a span of 4 years from 2019 in terms of number of AI and digital transformation projects that the business leaders are going to take. And this clearly is a priority for most organizations in their journey towards digital transformation. What really is important is to look at what are going to be the barriers to success in this. And again, this Gartner study shows that at the top of the list are skills of the staff and the quality of data. Uh, and to add to it, there is another study that was done by McKinsey, which shows that in addition to staffing skills, there is also going to be a challenge of making functional teams work together in this kind of technological environment, which otherwise, they are kind of used to working in functional silos. Okay, so so some of these challenges we have to look at. Do we have too much data, or do we have lack of data, or do we have missing data? And for that, we have to look at what are the data we could be using. If we have lack of data, how we can synthetically generate that data using first principles models. Again, in terms of AI, there are different techniques, and we have to see which is the right one to be used for the right application, whether it gives us the desired accuracy, and can we get that desired accuracy from the algorithms that are currently available to us. And I think most importantly, we have to look at or take a decision on how do we deploy these models when we are talking about scaling it at enterprise level. Is there going to be a single platform? Do we build up things using different tools, and how do they kind of work together so that there is greater interoperability in these AI tools that are being used by the community? So what we feel is it will bring in changes, both in terms of leaders looking at skilling their people with different skill sets as they move on towards this journey of digital transformation. They have to look at bringing changes in their processes that are currently being used in their organization, and they have to really look at the technology front. So we would say people, processes, and technologies. These are the three things that leaders would probably look at going forward in future to see how they really bring about this digital transformation that they want to bring about in their organization.
Definitely, and I think the way you pointed out that people, processes, and technology should work in collaboration, and leaders should embrace the evolving technologies like AI and big data, so that they themselves can change the processes and make it more efficient, and which in turn will be more productive for the company as well. Um, when we're talking about 2020, it hasn't been a great year due to the outbreak of COVID pandemic. However, it has also accelerated the adoption of technology in terms of automation, use of robots, drones, etc., helping in the supply of essentials or medical or healthcare for that matter. So I believe that 2021 is set to be another big year for technological advancement, and new solutions and systems will continue to aid business productivity and create new dynamic ways for a business to work. But for the advancement, there will be challenges as well, and technology plays a big part in a business, that it's important to be aware of these challenges and how to deal with them in the coming year. So kindly mention some of the major challenges the company has faced till now, and what solutions or what steps you had taken to overcome such challenges.
I mean, specific to the challenges that pandemic posed in front of every organization today was how to get their workforce to work from home. I think MathWorks being part of technology companies, for us, it was a little less challenging compared to many of the other organizations which are involved in, say, manufacturing goods. So we were able to fairly quickly adapt to the changing scenario, and we were able to get our staff well equipped to work from home and contribute to the organization's design and development process the way they were doing while working from office. From the sales organization perspective, our focus during this time was to remain in touch and remain engaged with our customers. And we have been able to do so to the best of our abilities. We have been able to support our customers and help them, to continue to adopt our tools in their own work environment. So I would say we have been able to, you know, adapt to this changing scenario fairly well and fairly quickly, and with least impact on our business. So talking specifically in the context of AI and data analytics, MathWorks today is recognized as a leader in Gartner's 2020 Magic Quadrant for Data Science and Machine Learning, based on their evaluation of MathWorks for completeness of vision and ability to execute on that vision, and that has given us a leadership position in their Magic Quadrant. And what this means is, we have been we have been in a way able to provide a comprehensive platform to our customers for solving the challenges of technology. And this has come because of more than 3 decades of our experience in supporting our customers manage complex engineering projects through our tools, our support capabilities, and our consulting services. And we continue to provide that to them. And as I said earlier, in this area, our objective has been and will continue to be to help engineers and scientists and equip them with the tools so that they can use this advanced AI or data science skills and add it to their experience, and then apply these skills for building AI systems successfully. Also, I think today we are very well positioned with our 2 platform products like MATLAB and Simulink, which would continue to help the engineering and scientific community to upgrade their skills and help them address the needs and challenges of engineering, address the challenges of engineering problems going forward.
Definitely. And I think I really like the point that no matter what challenges that probably every company faces with regards to technological adoption or with regards to anything for that matter, adapting to the changing scenario is very important. I think it's one of the most important elements that most of the companies struggle to do with. But once they're able to do that, I think most of the challenges are solved there itself. Um, wrapping up the podcast, Sunil, there are a lot of the data is growing faster than ever before, and the future of technology is even more interesting than what is happening now. I think we are at the beginning of a revolution that will touch every business and every life on this planet. Having said that, how do you see the future and the company in the future ahead?
Yeah, as I said earlier, I think we can hear all business leaders talk about this digital transformation, and this is here to stay. But organizations at the same time are really struggling with executing their digital transformation initiatives. As per a study conducted by McKinsey in 2018, fewer than 20% organizations are where they want to be when they look at their digital transformation objectives. So it is going to be challenging. It is going to be hard, and you know, as I said earlier, it's going to be basically looking at how we can classify the challenges into 3 different buckets of people, processes, and technologies. So we have to look at how do we continue to develop skill sets of the people which they may currently not have to undertake the tasks that are required to be done for this digital transformation to happen. So business leaders will have to look at skilling their manpower to be able to take advantage of this the technology that is going to drive digital transformation. The second one is to look at the processes, and the processes will need to change in some ways. So if the models are not shared beyond the teams that created them, then it's much more difficult for the entire organization to get involved. It's often not obvious what processes should remain the same and which need to change. So the business leaders will have to look at those processes and make the respective changes for successful adoption of digital transformation in their organization. And finally, talking about technologies, and some of these technologies may not have been fully tested yet. and a lot of these technologies need to come together and build that overall strategy for digital transformation. So business leaders will have to look at all these three things: how they can get the people with the right skill sets, how they can tune their processes, and how they select the right technology for enabling their digital transformation.